Now I would like to take a look at the goodness of fit of this regression. In order to do that, I first get rid of this bottom line here again. I would like to see whether including or accounting for additional factors helped us in improving the fit. Now, one way, as I said, in order to judge the goodness of fit is to look at the residuals first. So if I compute the residuals first for each of those houses, I can again, first of all, check whether the average is 0, and that's the case, as you see here. More importantly, I'm interested in the standard deviation of those residuals. It's the same 30 observations, the same 30 houses. As you see, we get now 42,700 left unexplained, whereas we had something like 50,700 when we only accounted for the living area. So one way of interpreting that is, if we want to understand what determines the dispersion in house prices, and we only have the size of the living area as an explanatory variable, we end up with about $51,000 plus minus unexplained. Whereas if we account for the overall quality, the condition, the year built, the age essentially, we're only left with around $43,000 unexplained, plus minus, in about 2/3 of the cases. Let me also state at this point, I'm using only 30 observations only for the sake of comparison with the previous regression. I would not recommend doing a regression, a multiple regression with only 30 data points. So, but we're going to do that in the next video, where we use the entire available data set. But for the time being, let's continue with the comparison to the simpler regression that we've done before. In the simpler regression, for instance, we had a multiple R, which is the correlation between the fitted values and the observed values. Now this multiple R has gone up to close to 0.6. The R square has gone up from 9% to about 35%. And as I already said, the standard deviation of the errors has improved from something like 52,000 to around 46,000. So the additional flexibility introduced by those additional explanatory variables has helped us to improve the goodness of fit. We're still left with considerable variation in the errors, which we could hope to reduce further by adding further explanatory variables. I'm going to do that in the next video. As a final remark, I would like to point out that the extent of improvement that we've achieved by adding 3 explanatory variables seems to be stronger if we look at the improvement in the multiple R, which has almost doubled, or in the improvement measured by the R square, which goes from about 10% to about 36%. I rather look at the improvement in terms of the reduction in the standard deviation of the errors that we make. And if we look at that, we see that we've actually only improved in dollar terms by something like from 52,000 to about 46,000, so roughly $6,000, which is maybe not that impressive as the improvement that is indicated by looking or comparing R square or multiple R's.